Alright, so in this video we're going to look at lesson 1-2. Now we're going to actually break lesson 1-2 up into two separate parts, only because in this lesson there's going to be a couple of new concepts as a whole in this chapter that it would be easier if we broke it up into two parts and only introduce one really new concept that you probably haven't seen before in this video, and that's dealing with what we call sigma notation. And then in the next video we're going to look at something called a weighted average, which is something else that I don't think you've seen before. All right, now these first three measures of what refers to, I should say, measures of central tendency, you should have seen back in algebra. But that's dealing with the mean and the median. Now the mean is just another name for the average. Okay, so when you think about your average you get on your quizzes or tests for a class, you're already familiar with that. And that's just where you add up all the numbers and divide how many there are. Or another definition of that would be divide the sum of the values by the number of values. And the median is what we call the middle number. Now the key though is it's not just the middle number, it's the middle when in order from smallest to largest. So let's look at this set of data here. So if I have 2, 7, 3, 9, 8, 8, and 5. So if I wanted to find the mean of those set of numbers, I would just add up all of those numbers together and divide by 7, because there are 7 numbers there. And when you do that, you would get 6 as your answer. Okay, so the mean of that data set would be 6. Now if I asked you to find the median of that data set, you would not just want to look at the middle number and say, oh, the median is 9. Because that would be wrong. Because we would need to first put those numbers in order from smallest to largest. So if I put those numbers in order from smallest to largest, we would get, we see there on the left, the 2, 3, 5, 7, 8, 8, and 9. So now the median, the middle number, would be 7. Now the way that you can get that middle number is by crossing out from outside to inside. To get that middle number is 7. Now that's relatively easy if we're dealing with a small set of data like this. But what if I had like 40 numbers and I wanted to find the median of those 40 numbers? Well, I wouldn't want to sit there and go alternate, crossing things out. That would just take too much time. So another way to get to that middle number is by, let's look at this concept. So here I have a total of 1, 2, 3, 4, 5, 6, 7 numbers. And if you think, well, if I just take 7 divided by 2, would that get me the middle number? Well, 7 divided by 2 is 3.5. Well, if we round that up, we would get 4 numbers, or the fourth number would be our median. Okay, now what if, instead of having, let's say if I took out this 9. So now I have 1, 2, 3, 4, 5, 6 numbers. Well, the median, or half of 6, would be 3. Well, but the third number is not our median. Our median number would be between 5 and 7. Now, if that ever happens, where we have two middle numbers, like 5 and 7 are two middle numbers, we would take the average of those two numbers, which in this case 5 plus 7 is 12, and half of 12 is 6. Or you can just think of what number is between 5 and 7. Well, that would be 6. So how do we put those in a bigger concept? So in this situation, we had an even number of items, and so we took half of those. So 6 divided by 2 would be 3. And so now if I were to always just increase by a half, so in other words, the 3.5 term, or the term between the third and fourth term, would be my median number. So if I had 20 terms in my set, 20 divided by 2 is 10. So that does not mean the 10th term would be my middle term. It would mean the 10th and a half number would be my middle term, or the number between the 10th and 11th term. So it's just a little trick that you can use to quickly find the median, again, when they're in order from smallest to largest. Now the mode is not a measure of central tendency. It's something different, but it's representing the number that's listed the most. So if you think of mode and most, that's how I like to remember it. So MO is in both of those. So the mode is a number that's listed the most. So in this situation, the mode would be 8. All right, so that should be review. Now this is what's new. We're going to deal with what's called summation notation, or it's also called sigma notation. And you'll see why it's called that in a second. So there's 3 parts to summation notation. First part we need to be familiar with is what we call subscripted variables, like x sub 1, x sub 2, x sub 3. So notice I'm saying sub a number. So that's referring to a subscript. So the subscript here would be the numbers that are written down below there. So that's how we identify each of the n data values. Now, the reason why we also call this summation notation, or we also call it sigma notation, is we use the Greek letter sigma. That Greek letter for sigma looks like a funky E to indicate that there is a sum. Now, if you ever work with an Excel spreadsheet or even a Google Sheet spreadsheet, you're going to see that symbol. And that symbol is just a way to find the sum of a set of numbers in a row or in a column. So that's what we use that symbol for, is to represent a sum. Now we use what's called the index to indicate which of the subscripted variables are being added. Now you might be wondering, okay, what does all this mean? Well, let's look at an example here. So over on the right, we have that table of all the different jobs and their different salaries in terms of thousands of dollars. So the VP assistant, so the assistant to the vice president, makes $30,000. The vice president makes $150,000. So that's how we can read that table. Now, if I wanted to indicate that I wanted to find the sum of all of those different salaries, so there's 15 different employers or employees in this company. So we would just say that I equals 1 represents, so the I is your index. Okay, so we usually use I or N to represent the index. So this is saying that the index, we're starting with the first term, and we're going to end with, so at the top there, that tells us where we're going to end at. We're going to end with the 15th term. Now over on the right there, it just says X sub I. That just means that we're just going to take each of those values and add them together. Now sometimes we might see something like this. Like maybe we want to give each person a $2,000 raise. We're in those numbers there, we're in terms of thousands of dollars. So if I wanted to represent that, we would just say X sub I plus 2 would represent that we would just add 2 to each of those person's salaries. So if they were making $65,000, in the table it just says 65. So if I want to give them a $2,000 raise, we would say plus 2. So if I wanted to figure out how much total it would cost if we would give everybody a $2,000 raise, that's what we would do. X sub I plus 2. So we would add 2 to each of those numbers and then add the numbers all together. Where if I had something like this, this would mean that we would add up all the numbers first and then add 2 to the final sum. So that's the difference between the way that we would write those two different numbers. But if we just see X sub I there with nothing listed after it, that just means that we don't do anything to each of the numbers. We leave them as is. Now if I just wanted to focus on just the custodian workers. Now the custodian workers are employees numbers 8, 9, and 10 in that table. So instead of starting with the first term in the table, we would start with the 8th term. We would want to end with the 10th term. So that's how we would identify just adding together just the custodial workers. Oh, and as far as how we would read those, down below in italics, if I wanted to read what's in that purple, I would say the sum of X sub I as I goes from 1 to 15. Or if I wanted to do just the custodial workers, the way that we would read that is it says the sum of X sub I as I goes from 8 to 10. Don't worry too much about that, but that's how we would read it. All right, now remember, that symbol for sigma represents the sum, not the mean. That's where some people get confused. The sigma just represents the sum of a set of numbers. So if we want to indicate that we're trying to find the mean of a set of numbers, we're going to use multiplying by the inverse instead of dividing. What does that mean? Okay, we'll think about it for a second. If I had that set of data that we were dealing with at the very beginning, where we had 7 numbers in that set, so to find the mean, we added up all the numbers and divided by 7. Well, that's one way we could do it. So we could divide by 7, or we could multiply by the inverse, the reciprocal of that. So the reciprocal of 7 would be multiplying by 1/7. So multiplying by 1/7 and dividing by 7 would get the same result. Or in this situation, dividing by 15 is the same as multiplying by 1/15. So the mean in this set of data, we could represent it 2 different ways. So again, I personally prefer multiplying by the reciprocal, multiplying by 1/15 as opposed to dividing by 15. And just because you can see those 2 different ways that we could write them, in the first way looks much more cleaner than that second way. But technically you could do it either way, but you just want to be familiar with seeing both ways. So if on a test, if you see it this first way, you'll understand that that's just trying to find the mean of a set of data. All right, so let's end by looking at this example. So here we have, it says a full parking lot has 46 cars. Let P sub I be the number of people who rode in the ith car parked in the lot. What does this symbol represent? So take a second and think about that. What are they trying to ask us to do with that symbol, with that That's sigma notation. So why don't you pause the video and think about that for a second. Well, what did you get? So I'm not going to take the time to write it down, but you should have written down or thought about this, that what they're asking us to do in that situation is they're asking us to find the total number of people that rode in the cars in the parking lot. Because there's 46 cars in the parking lot, and piece of I represents the number of people that rode in each car. So in the first car, there might have been 3 people. In the second car, there might have been 2 people. In the third car, there might have only been 1 person. So adding the number of people that came in each car for all 46 cars would tell us how many total people that rode in the cars in the parking lot. So now in part B, it says use sigma notation to express the mean number of people per car. So why don't you guys go ahead and pause the video and write out how you could represent that using sigma notation. Now, we're not actually trying to find this total because we don't have the numbers of people in each car. We're just trying to figure out how we would write it out to show, to illustrate that that's what we're trying to find. So pause the video, and I want you to write this out as far as how you'd represent that. All right, well, how did you do? Again, you could have done it either one of these ways. My personal preference is the first one, to say that we would find the sum of those 46 cars, and then we would multiply it by 1/46, or like I said, you could divide by 46 as well. So that is how you do sigma notation. So again, sigma notation is something new, so you'll get a chance when I see you in class for us to review that together and then to work on your assignment in class. In the next video that we'll be doing the following day, you'll be learning more about what's called a weighted average. So with that, hopefully again you took good notes, and we'll come to class with some questions if you have any from this portion of the lesson.